Why has it gone quiet all of a sudden? Oh, the stenographer is typing out the stuff that I'm saying on the screen over here. GitHub. Python. Sesquipedalian. Well, thank you all for being such a fantastic audience. Up next, we have a presenter who knows a lot about writing tools for developers. He's been doing it for quite some time now, and he's going to tell us about building better tools for ourselves. Please make welcome Alex Gaynor.
Hi, everybody. I'm Alex, and this talk is going to be about how developers, that is us, can build more tools for ourselves and for our teams. My hypothesis is that as developers, we like writing big, fancy tools. We like making new web frameworks and new libraries that we can distribute, but we don't make small tools to make our own lives easier. So this is going to be about how we can do that for ourselves. A little bit about me. I'm a Washington, D.C.-based Pythonista. I do lots of sort of open source community stuff, and I like bagels and delis a whole lot. I'm very excited to visit Kenny and Zooks while I'm in town. I work for the government. If you're looking for work, we are hiring people to do big, important projects. So if the thrust of this talk is going to be about how we should write more tools for ourselves, I wanted to briefly cover the history of tools sort of as I remember it, so going back maybe 5 or 10 years. And because I think the trajectory of the past is useful in helping us attempt to build the future. So when I first started programming, about the only thing you could reliably assume a software project would have was version control. It wasn't Git back then, but basically everything I worked on had version control at some point. Issue trackers were common, but not universal. I would occasionally work on a software project that didn't actually have an issue tracker. There was just a mailing list or an IRC channel or some sort of internal company discussion forum. So this was about the only thing you could assume. And at this point, issue trackers are near universal, but that was sort of a gradual thing to occur. Continuous integration, when I got started, was not universal. Now it's extremely common. A bot of some sort that automatically runs tests whenever your code changes on trunk, pretty common and increasingly more and more common thanks to tools like Travis CI. In the past few years, particularly, code review tools have become pretty in vogue. Now most companies and OSS projects have some sort of formal code review process, often supported by a tool such as Gerrit or Fabricator or GitHub, something to keep track of all of the different comments and patches that are being proposed. It's basically expected now for a project to have some sort of deployment automation. It's far less common nowadays to see people manually SSHing into servers to update them. Nowadays, using something like Fabric or Chef or maybe a hosted service like Heroku to deploy your projects, very common. So these are sort of the things I see today that many, perhaps even most sort of healthy projects have all these things. I think these are all great ideas. Every project should do them. They're not quite universal yet, but hopefully they will be. There's also another set of tools that I now see as being pretty common and gradually getting more popular, but not quite to the same level of ubiquity. So perhaps the most powerful of these is having continuous integration for pull requests. Once upon a time, it was incredibly common that your Jenkins or your BuildBot only ran on changes to trunk and maybe other branches that you went out of your way to set up. Largely driven by Travis CI's introduction of this feature, the ability to automatically run all of your tests on a proposed change rather than a merged change, I think is an incredible advancement. So now you're aware that whether tests pass or fail before they're ever landed. I remember at a very early job, it was, if you merged a patch committed directly to trunk and it broke the tests, this was, was a big deal. Everybody made jokes. Now it's basically accepted that any patch you land will, of course, be passing tests. You already ran the tests before you even got to merge it. So this practice is interestingly far more common in open source, I found, largely because of Travis CI. But things like Jenkins and BuildBots have this functionality as well, so folks are gradually adopting it. Another thing that's increasingly common, again, more so in open source I found, is linters of various sorts. So like pep8, flake8, things like that. Many folks think of linters as mostly stylistic tools, but they're also sort of more tailored lints. Things like Bandit, for example, which checks for bad security practices in Python. So I think of lints as sort of any tool that tries to make an assessment about your code without actually attempting to run it. One note I'll make about linters is that other communities, such as Rusts and Go's, have been, interestingly to me, moving away from sort of style-checking linters towards automatic formatters. So imagine if instead of flake8 telling you what was wrong with your code, it would simply fix it for you, as GoFump does. So I think this is a super interesting pattern, and I'm curious if it'll propagate backwards to other programming languages. Another trend is automated coverage tracking. So coverage.py has been a module for a very long time and very popular, but my experience was 5 years ago. What happened is, once a month, once a week, whenever somebody got around to it, somebody would manually sort of run coverage on their laptop and see what the status was. Now there are services and Jenkins plugins and things like that that make it very easy to have automated stat tracking, so every build, you know what the coverage of it is, including integration with continuous integration for pull requests, knowing what impact a pull request has on your coverage before you even merge it. So you can enforce rules like, I do not want to merge patches that reduce coverage too much. Imagine you're a large company, you have a ton of projects, they all interoperate, you're not quite sure which one of your projects implements some functionality, you want to find out all the different projects that some function or some module is used in. So live grep is a service which is unfortunately not as popular as I'd like it to be, that provides instantaneous regular expression search over large amounts of code. So they have a hosted version that runs over the top 10,000 GitHub projects, as well as an open source version. But I think tooling like this for understanding our code is an excellent example of tools that we could build for ourselves. A similar one that is also not as popular as I'd love is a small tool called MentionBot. It looks at your pull request, sees which lines are changed, and who's previously been working on those lines in that file, and suggests reviewers for your pull request who might be appropriate to work on those. I think this is another example of a really good pattern of building small tools to improve workflow. So those are sort of a set of tools I see getting increasing adoption now, and I imagine in 1 or 2 PyCons, those will be almost as common as the first set of tools. The other thing that's become more standard, largely driven by good tools for this practice, is a really common workflow around creating small branches that are lived for a short period of time, turning those into a pull request, getting code review, and then somebody merging your pull request into master, and a little while later it being deployed. I think this is an incredibly powerful pattern. There's lots of great talks on how to implement that for your project. The rest of the material in this talk kind of assumes you have a process that looks something like that. I develop some code, I send a pull request, there's code review, it gets merged. So I think in terms of building tools for yourself, at least of the type I'm going to describe, it's helpful to start from a position of, I already have sort of that workflow implemented, because I find it gives you lots of useful hooks into the process where you can add your own tools, and I'll point that out as we go along. So the rest of this talk is about how to build better tools for our development teams and your specific processes. As developers, we have the ability to write computer programs, but too often our own teams are a hodgepodge of undocumented or manual processes. And I think there's all sorts of simple, fairly easy to create tools that your team might want to implement its own process. This is because my central thesis is, whenever possible, you want your process to be implemented by a tool rather than by hand. This is for a couple reasons. One, automation scales better. Human-enforced processes will break down as your team gets larger or as you just try to encode more processes. Secondly, if you encode your processes and your workflows into a tool, this has the cool benefit that when you're ready to change your process, make improvements to it, it becomes an act of sending a pull request. To change your process means changing the code that enforces it, rather than updating, say, a Word document that describes this is how we work. This means that it's easy to see sort of functionally what the expectation of a change is. There's no sort of guesswork or ambiguity. There's, I see what the change in the code is. I see what the new requirements are. It also makes it easier to discuss and debate the merits of things. It's possible to experiment with, let's turn this new functionality on for half of our pull requests and see if we like the new process better. So it scales in this respect as well. It gives you much more flexibility and ability to experiment when you have things encoded in tools. Finally, it means you always know what the correct behavior is. Human-defined processes have an interesting property of deviating between what you've documented as how it's supposed to work and how it actually works. Sometimes this is okay. People use their own judgment to make processes more efficient. Other times it means they bit rot effectively. Processes gradually diverge until no one quite remembers why it works this way. And we know it's not what we wrote down, but we're pretty sure this is better. When your processes are encoded in tools, you avoid this problem because you have a predictable, repeatable execution of your processes. So, good news, if we're going to implement some tools, lots of our existing tools have APIs we can leverage to integrate. It would be a horrid thing if in the process of building 5 new tools to optimize our team's workflow, we had to interact with 5 new websites or 5 new command line tools. That clearly would not scale. We have APIs that let us integrate new enforcement of our workflows into our existing tools. So for the rest of the talk, the examples I'll use are all using GitHub's API, but the concept should translate to other issue trackers and code review systems. I'm just using GitHub because it's familiar to most people, and it is a publicly accessible API. So what kind of APIs exist? Well, on issues, we might be able to create a new issue. If we have a program that knows something is wrong, it can file an issue. Lots of places I've been, if something is detected as wrong, maybe shoot an email, and of course, email gets lost, doesn't get sent to the right people, nobody else besides the target of the email knows what the problem was, so issues give us visibility. We can also mess with labels or assignees to keep things organized, and leave comments automatically to add additional information or context. With pull requests, we might be able to create a pull request, so have a program propose some change to our project. We can, again, organize things. We can have a bot that performs some sort of automatic code review, like some sort of linter on steroids. And GitHub has the idea of commit statuses, so we can, in a similar way to CI, say whether something is passing or failing and whether it's safe to merge. So let's have some examples of how this works. To get started, we can use github3.py, which is a fantastic set of Python bindings to GitHub's API by Ian Cordasco. So to get started, we create a GitHub client. For this example, I'm storing the username password in the operating system's environment. Small sort of production note. Don't use your own account's username and password. I recommend creating a second account for bots and create single-use account keys that just have the minimal permissions you need for whatever you're working on. So next, using GitHub's client, we can get a repository object. We're getting the Django accounts, Django repository. The repository object has methods for most of the API calls we'll want to make. So one tool we might want to make for ourselves is a tool to scan our website and check when our HTTPS certificates expire. Pretty common, people forget. If the certificate expires, users get the ugly red lock sign, and they have to click through. Nothing good. So we want to be proactive and aware of this, and we want to track it in our issue tracker, because that's where we keep track of all the ops work we need to do, so that everyone is aware, and this can get worked. So we start with a small function, which gets the expiration date for an SSL certificate. Relatively straightforward. We mess with the socket module and the SSL module. We get the not after or expiration date. I'm not going to spend a ton of time diving into the details of this. It's not really the subject of this talk, but given a host name, we can get back a date time for when it expires. And so putting this together, now that we have that function, we can loop forever, so our process is always running. And then given a bunch of domains we want to check when their certs expire, we get an expiration date for each cert. And if that expiration date minus the current time is below some threshold, say a month, we file a new issue for ourselves, and then we sleep, and in an hour we go back again to go looking for more expired certificates. So clearly the important bit is, how do we file an issue? Well, it's easy. We simply call the createIssue method, very creatively named. So Django, again, our organization and repository name, the title, letting us know that there's a certificate expiring soon, a body telling us roughly the same thing, also including the expiration date. I've assigned it to myself, my GitHub username Alex, and I'm attaching a label to it, SSL cert, so that if somebody wants to look for all of our expiring certificates, it's relatively easy. And that's genuinely all it takes to give ourselves a bot that will automatically file issues for ourselves and keep ourselves aware of any upcoming expiration. An exercise you might implement in the future, right now this bot will file a new issue once every hour until we fix it. Probably suboptimal, unless you have a super on-the-ball ops team. So exercise to the reader is to update the code to not file an issue if we already have an open issue. And perhaps going even further, to leave a comment as the time ticks down. So we get under 15 days, now I'm going to leave a comment urging people to take a look at it, perhaps automatically adding it to the current sprint milestone. You can imagine really expanding this to make sure things are prioritized correctly. So now let's take an example of playing around with pull request APIs. So let's say our company has a fantastic security team that really wants to help out all the development teams. But they're also super busy. There's always more work than they can possibly get to. And so they're not quite sure how to prioritize given all the exciting work that's going on. We created a security label in our issue tracker to let them know which sort of pull requests deserve a little bit of extra attention from them and help them prioritize. But people keep forgetting to attach it. They'll make a change, they'll get review from the other teams, but they'll forget to add the security label, and so the security team won't get around to looking at it. Why don't we create a bot that will automatically add the security label if it thinks it's relevant? So an example of something that might always be relevant is anytime we touch a cryptography file, that means the security team ought to take a look. So most APIs, traditional APIs, we make HTTP requests to GitHub servers. GitHub's webhooks, by contrast, make HTTP requests back to our servers. So when a certain event that we care about, say a pull request being created or a pull request being updated, occur, GitHub will make a request to us and let us know what's going on. So in the web framework of your choice, we create a simple function that takes a request, and we've got a little boilerplate here. So GitHub sets a header letting us know what event has occurred. So in this case, if it's not a pull request event, we don't care. Then we load up the body of the request, which is JSON, and it has an action field letting us know what the action that occurred on a pull request is. In this case, we only care about opened, reopened, or synchronized. So opened, straightforward. Reopened means after a pull request was closed for some reason, if it gets opened again. And finally, synchronized is, I find, a slightly confusing name, but really just means somebody pushed more commits to our pull request. So we've got this body loaded up. Now we grab the issue corresponding to this pull requests. Pull requests on GitHub have the interesting property that they are both issues and pull requests. So we grab both the issue and the pull request with this number, and we grab the files that are impacted by the pull request. So we go through each of the files and get the file name. And then we check if our cryptography file is impacted. And if it is, we go ahead and add a label to it, letting folks know that this touches cryptography, it's a little security sensitive. We love additional review if we can get it. So those are a few concrete examples that we sort of walk through how to build leveraging these APIs. What are some other examples of tools we might want to build for ourselves using these sort of building blocks? You're a big company, you've got 100 projects, they all use Django. When a new Django security release is issued, different teams have to run around updating it. Often, some teams don't get the message, so the security team has to chase after them, telling them, hey, please update this, maybe sending pull requests themselves. Something we'd like is if we could just have a bot that would automatically go through all of our 100 repositories and automatically send pull requests to each of those, updating a version we know is vulnerable. So we can imagine a similar hook that leverages this pull request, or a bot that creates pull requests rather than simply responding to them. So we know there's a version upgrade. We go through each project and we find its requirements.txt, and if it still has Django equals, the bad version, we send a new pull request automatically, leveraging GitHub's APIs for creating pull requests, for making commits, to automatically give teams the information they need to update, and in fact, doing most of the work for them. One of the processes I have found possibly most painful in all of developerdom is reviewing changes to the user interface of a project I'm working on. It's horrible. For any other sort of change, I write tests, I review the tests. It's very easy to validate correctness. When something in the UI changes, first of all, sometimes it can be hard to tell. If it's a small detail accidentally changed in a large pull request, it's easy to miss the difference. And even when there is a difference, I'm not always sure, is it correct or not? So we can imagine a system that sort of helped automate this, leveraging our ability to create screenshots. So imagine something like this. GitHub sends a webhook over to Travis CI telling it to run our tests. As part of our tests, using some sort of WebKit, headless WebKit thing, we capture some screenshots of what our website looks like. Instead of just comparing them to static, pre-computed, expected screenshots and failing the tests, instead what we can do is send those screenshots off to a service we control. That service can check, how does this screenshot compare to the previous one? And if it's different, then it can go ahead and leave a comment on GitHub saying, hey, I noticed the screenshot for this page changed. Was that change correct? Now we have sort of an ability to know, did something change reliably? No more relying on human beings to notice, hey, does this web page look different? We can proactively say, yes, it definitively changed. I need you to look at that. This gives us a human element to code review, saying, hey, this definitively changed. I need you to approve it. I can't say automatically whether this is correct, like a traditional test, which has a pretty firm true-false assertion. This is, I need your input human. You say it's okay? Great. I now mark my commit status on GitHub as passing, and when the pull request is merged, I update my expectation. Now I expect other pull requests that change this to have this new look, and if they don't, I inform them. So adding human beings to the code review workflow, specifically around, or really the testing workflow, not the code review workflow, saying, hey, was this change correct? Let's say your company has a process where things have to be reviewed by two people, one front-end developer, one back-end developer. You can imagine a bot that started off with a failing pull request status and was triggered by comments where it knows what group each person's in. So if I, as a back-end developer, leave a comment saying, this looks good to me, now the bot knows it's met one of the requirements, and the pull request only becomes mergeable when a front-end developer goes ahead and leaves a comment. So encoding in our bot the process of who needs to approve things, driven by comments, so other people have visibility into what's going on. These are just a few examples of tools you might build for yourselves to encode whatever your team's workflow is. I'm hoping this has inspired you to find all sorts of different places your team has implicit processes or manual processes, and building small tools to improve those workflows. One of the perhaps most surprising experiences I've had since I started adding all these sort of small bots to my workflow is just how small these are. Often on the order of 10 lines of code written in half an hour, I can add processes that save lots of time. It used to be that a regular issue on one of the projects I work on was we would ask another team for something and we'd totally forget about it. Now we create issues, leave a label on them saying, hey, we asked another team for something, and if we don't document the response within a week, we automatically have a bot that leaves an issue saying, hey, you should probably check back in and see what's the deal with that request. Making these small process changes has made us much more productive, given significantly more visibility to the types of processes we're implementing, and help people not lose track of things. Thanks very much for listening, and I'm happy to take questions.
Now you'll be pleased to You'll be pleased to know that every other room is running slightly late, so you don't actually need to leave to rush here. If you have a question, line up at either of these two microphones over here. I can see there's one over here, so we'll take you.
Thank you for your talk. It was excellent, as always. I've watched a lot of your talks. You seem to talk a lot about using bots to do those processes, to automate them. I was wondering, have you experimented with using a messaging system so that the systems put their events into a message bus that then you can hang any of a consumer off of, and if that is a better pattern than just creating a self-contained system that needs all the inputs and then does all the outputs?
So I can imagine a world in which I wanted to propagate events to maybe I wanted to put it in Slack and GitHub, or send an email and put it in Slack, something like that. Most of the work I've done has been pretty specifically targeted at, hey, we know we need this, we know we need an issue, so we're just using an issue. Yeah, if I had more communications tools I was using, I might look at an approach like that, but I haven't played with that now.
Cool, thank you.
Next question from over here.
Do you have any tips for debugging and tuning bots, especially those that react to events like, oh, this case is a week old, stuff that's hard to...
So debugging bots, first, like almost anything, add tons of logging. Another thing I found particularly useful is if you have a bot that responds to a specific event from GitHub, say a pull request open or synchronize, create a secondary tool for yourself to make it easy to manually trigger that webhook for a given pull request number. So basically synthesizing what that request would look like automatically goes a long way, basically giving you sort of a retry behavior. Particularly useful if you have a bug and you want to re-trigger the pull request.
Okay, we'll take this question over this side and then this one.
So if these things are sort of blockers for the workflow, it seems like you might need to worry about maintaining high availability for these kinds of things. And I'm wondering if you have services or architectures that you, where do you run these things so that you know that they're not going to get in your way and make that your business now?
Yeah, so my favorite pattern is find ways to share infrastructure with things you already care about. So if you deploy your whole website on Heroku, also putting these bots on Heroku is an example. You're already investing, or really Heroku is investing in making that platform highly available. Definitely an important point.
Yeah, over there. Over there, thanks.
Hi, thanks. I just wanted to mention for your visual differencing of screenshots, Brett Slatkin actually made a cool tool called Depict It that does exactly that.
Awesome.
So we can develop more tooling around it.
Do we have any more questions? It doesn't look like it, so if everybody... Oh, wait, we have one over here. Excellent.
What can't you make a tool for? What have you tried and failed?
What can't you make a tool for? So probably the thing I have seen fail most often with tools is trying to make a tool that provides visibility to something where not being visible is important. So if you're having two teams that are having trouble working together, a tool that sort of highlights that, in some organizations adds a lot of value. It makes it clear that something needs to be worked out. In some organizations, just adds more friction. People don't like acknowledging that. So that is an example of something I've seen fail. Yeah.
Thank you.
Looks like we have another one.
Hi, great ideas. I really like the automation of all these processes. My job, we have a requirement to be able to communicate these things to non-technical people. I'm in the healthcare industry, so do you have any suggestions on how to automate, alerting QA to processes when they may not be technically savvy?
Yeah, so a lot of the examples here, or really all the examples, are about using GitHub, since that is where developers of the audience are. I think the most valuable thing when you're building any sort of tool is going to where your audience is. So if your audience has some preferred tool, some way of getting notifications, some way of prioritizing your work, integrating with whatever that platform is so that they don't have to come out of their element to get informed.
Well, it looks like we have no more questions. Everybody, please thank Alex Gaynor.
Thank you, guys.